In this video, we will discuss top 20 technical interview questions which can be asked to the mechanical engineer. So the very first question, what is pattern? The answer is, a pattern is a replica of the object to be cast, used to prepare the cavity into which the molten material which will be poured during the casting process. So here you can see the pattern. This is nothing but the pattern. So it is used to prepare the cavity inside the mold. This is known as mold, which is made in two parts. The upper portion, that is known as scope. The lower portion is known as drag, and the cavity is prepared inside the cope and drag with the help of this pattern. After preparation of cavity, the molten metal is poured inside this cavity and it is then allowed to solidify. The solidified part is known as casting, or the entire process is known as casting. So the pattern is nothing but the replica of the object which is to be cast. Next question, list out the various pattern material. So the various pattern material are wood, metal, plastic, plaster, waxes and rubber. Now we will discuss one by one material in detail. The first one, that is wood. The most commonly used pattern material is wood. The main reason being the easy availability, low weight, and it can be easily shaped and cheap. The example is pine and teak wood. Then the metal. Metal patterns are extensively for casting because of their strength, accuracy, good dimensional stability, durability, and smooth surface finish. Many materials such as cast iron, brass can be used as a pattern material. Aluminium and white metal are most commonly used. These materials are lightweight. It can be easily worked, corrosion resistant. Then the third material, that is plastic. These are also used as a pattern material because of their low weight, easier formability, good dimensional stability, smooth surface and durability. The example of plastic, that is epoxy resin. Then the next material, that is plaster. It has high strength, it can be easily formed into a complex shape and can be used only for the small pattern. The example is gypsum cement. Then the next material, that is waxes. Excellent material for investment casting and it has good surface finish. Examples are paraffin wax, beeswax. The last material, that is rubber. It is mainly used for investment casting. The example is silicon rubber. So investment casting is one of the type of casting where waxes or the rubber patterns are used. Next question, what are the advantages of using wood as a pattern material? The answer is, the main advantage of wood is that it can be easily shaped and it can possess low weight as compared to metal pattern. Wood is optimal for very large casting and small quantity production. One of the disadvantages of wood pattern is the distortion of dimension due to the absorption of moisture. Next question, what are the advantages of using aluminium as a pattern material? The answer is, metal pattern is strong. The life and the dimensional accuracy of the pattern is more. Change in shape does not occur due to the moisture. It can be used in machine molding. It is suitable for mass production. Metal surface can be smooth and hence very good impression of the pattern can be obtained in the mold. Next question, list out the factor for selecting the pattern material. So we have to consider size and shape of the object to be cast, the volume of production, then the surface finish and dimensional accuracy required, then the possibility of design change, molding method used, and the cost of the pattern material. So these factors should be considered while selecting the pattern material. Next question, what are the types of pattern? So the various types of pattern, that is single piece pattern. Here you can see the pattern which is made out of a single piece, that is known as single piece pattern. Then two piece pattern. Here you can see the upper portion and the lower portion, they are connected together. So this is two piece pattern. This is nothing but multi-piece pattern which is made up of three parts, the upper part, middle part and the lower part. Then the loose piece pattern. So this is the main part and this is nothing but the loose pieces, they are attached to it. So this is known as loose piece pattern. Then cope and track pattern. So this is the upper portion, that is cope, and the lower portion is known as track. So this is known as cope and track pattern. Then sweep pattern. So this is an example of sweep pattern. It is rotated around its axis so as to prepare the cavity. This is shell pattern. This is skeleton pattern. So number of parts is attached to it, that is why it is known as skeleton pattern. Then segmental pattern, here you can see it is in different segments. Then follow pattern, match plate pattern. So here you can see one plate is there, and on that plate the two parts are attached, that is why it is known as match plate pattern. And the last one, that is gated pattern. So here you will pour the molten material and then it is distributed to various cavity through the gates, and hence it is known as gated pattern. Next question, what is the use of dowel pin? So first of all we will see what is the dowel pin. Here you can see this pattern is made into two pieces and they are attached together with the help of this pin. So here you can see the pins. Here also you can see the pins. So that is known as dowel pin. So what is the use of that dowel pin? So split pattern is usually made up of two parts. One part will make the lower half of the mold and the other part will make the upper half of the mold. These two parts are fitted correctly with the help of dowel pins. Next question, what is the need of loose piece pattern? So here you can see the example of loose piece pattern. So this is nothing but the main pattern, and A and B, those are loose pieces attached to that main pattern. So loose piece pattern is used when pattern is difficult for withdrawal from the mold. Loose pieces are provided on the pattern and they are the part of the pattern. The main pattern is removed first, leaving the loose piece portion of the pattern in the mold. Finally, the loose pieces is withdrawn separately, leaving the intricate mold. So here you can see this is the main part, and A and B, those are the loose pieces, they are attached to the main part. So firstly, the main part is removed from the mold and after that the loose pieces are removed so that you can get a cavity which include the main part as well as loose pieces. If you remove this pattern completely, then your the cavity will get distorted. Okay, so first the main part will remove and then loose pieces get removed carefully. Next question, what are the pattern making allowances? The answer is shrinkage allowance, machining allowance, draft allowance and distortion allowance. These are nothing but the various types of allowances. They are provided over the pattern. Next question, what is shrinkage allowance? So the shrinkage allowance is classified into category liquid shrinkage and solid shrinkage. So we will discuss liquid shrinkage first. It refers to the reduction in volume when the metal changes from liquid state to the solid state at the solidus temperature. To account for this shrinkage, riser which feed the liquid metal to the casting are provided in the mold. So during solidification, what happen? The metal gets shrink. So we will provide an extra molten metal to counteract this problem. Then solid shrinkage, it refers to the reduction in volume causes when the metal loses temperature in a solid state. To account for this, shrinkage allowance is provided on the pattern. So the solid shrinkage is provided over the pattern, whereas for liquid shrinkage, the extra molten metal is fed in the riser. Next question, what is draft allowance? So here you can see the draft allowance. See the first figure and second figure. So here the draft is not provided. So while removing this pattern, this wall may get damaged, whereas here the draft is provided. So this pattern will get easily removed and your wall will not get damaged. So the by draft is meant the taper provided by the pattern maker on the vertical faces of the pattern so that it can be removed from the sand without tearing away the sides of the sand mold and without excessive wrapping by the molder. So here you can see here no draft is provided over the pattern. So when you remove this pattern, the walls get damaged. Here the pattern is the draft is provided over the pattern. So when you remove the pattern from this mold, this wall will not get damaged and you can easily remove the pattern from the mold. Next question, list out the various molding tools. So here you can see the various molding tools, means the tool which are required to prepare the mold, that is cavity. So the hand riddle, shovel, pin reamer, vent wire, spirit level, sprue cutter, mallet, swab, lifter, strike off bar. These are the various tools which are required for the preparation of mold. Next question, what are cope and drag? So in foundry work, the term cope and drag refers respectively to the top and bottom part of the two-part casting flux used in a sand casting. So here you can see the cope and drag, the upper part, this part, the complete upper part above this parting line, that is known as cope, and the lower portion below the parting line, this is known as drag. Next question, list out the properties of moulding sand. So moulding sand is used to prepare the mold, and it should have some properties. The very first property, that is refractoriness. It is the ability to withstand high temperature of the molten metal. So in casting process, we heat the metal and then we pour the molten metal inside the cavity. So your sand should withstand that high temperature. Then green strength, moulding sand that contain moisture is called as green sand. The green sand should have enough strength. Green sand compressive strength is around 130 to 160 kilopascal. Green shear strength, that is 100 to 40 kilopascal. Then dry strength, when molten metal is poured into the mold, the sand around the mold cavity is quickly converted into dry sand. At this stage, it should retain the mold cavity and at the same time withstand the forces. So when you pour the molten metal, the sand near the molten metal, that is quickly get converted into the dry sand. So that sand should withstand that pressure of the molten metal. The next one, that is hot strength. It is the strength of the sand that is required to hold the shape of the mold cavity after all the moisture is eliminated. Then permeability. Permeability or porosity of the sand is the measure of its ability to permit the air to flow through it. That is known as permeability. Then grain fineness number. It indicates the average grain size distribution of a given mold. Greater the GFN, lower the grain size. Then flowability, the ability of the sand to flow over and around the pattern. That is known as flowability. The sand should easily flow over the pattern so that we can prepare the desired cavity. Then adhesiveness, this is the property of the sand mixture to adhere to another body. That is known as adhesiveness. And then cohesiveness, bond formation between the two sand grain. That is known as cohesiveness. Next question, what are the types of moulding sand? So here you can see the different types of moulding sand, that is green sand, dry sand, loam sand, facing sand, parting sand and the core sand. So here you can see the loam sand, green sand and the dry sand. These are nothing but different types of moulding sand. Next question, what are the elements in gating system? So here you can see the complete gating system. The various element is the pouring basin where you can pour the molten metal, and then the sprue through which the molten metal can be delivered to the sprue basin. This is nothing but the sprue basin. Then there is a runner. Then the gates are there. So the molten metal is poured inside the pouring basin. Then it enters into the sprue. Then it is collected in a sprue basin and then it is distributed to the runner. After that, through runner, it will go to the gate, and through the gate it will deliver to the cavity. And this cavity is nothing but this cavity is produced with the help of pattern, and finally we will get a casting out of it. Okay, so the various elements are pouring basin, sprue basin, runner and the gates. And this has to be carefully designed to get a good quality of casting. Next question, what is the function of a riser? So here you can see the riser. This is nothing but the riser. Okay, so the riser, it is also known as feeder. It is a reservoir built into the metal casting mold to prevent cavities due to shrinkage. Most metal are less dense as a liquid than as a solid, so casting shrink upon the cooling, which can leave a void at the last point to solidify. So here you can see a complete mold. Now the upper portion is known as cope, the lower portion is known as drag. This is nothing but the cavity. Now the molten metal is poured inside the sprue. Okay, so this is the runner, and then it enters inside the cavity through the gate. After that, the excessive molten metal is collected into the riser. Now what happens during solidification? The molten metal get contract, and then we have to feed the extra molten metal during the solidification, and that has been done with the help of this riser. Because what happens when the molten metal is in liquid stage, so it occupies more volume, and when it gets solidified, it will become dense and it occupies less volume, and hence during solidification the extra molten metal is required. If you do not provide the riser, then you can find the cavities over here. Next question, what are the types of core? So the answer is green sand core, horizontal core, vertical core, balance core, hanging core, and drop core. So these are nothing but different types of core. The first one, that is horizontal core. Here you can see the core is placed in a horizontal location. Then the vertical core, here you can see the core is in vertical position. Then this is a type of balance core. Then the hanging core, here you can see the core is hanged. Then the drop core and the kiss core. These are nothing but the different type of core. So the core is basically used when you want to produce a product with the cavities. That is the use of core. So whenever there are cavities inside the casting, then it is known as then you can use the different type of cores. Next question, what are the different microstructure of a steel? This is also a very important question because in casting industry mostly the steel is used. So the different microstructure in the steels are austenite, ferrite, cementite, perlite, ladyburite, and martensite. Next question, list out the various casting processes. The answer is sand casting, centrifugal casting, gravity die casting, continuous casting, pressure die casting, chilled casting, malleable casting. These are nothing but different types of casting processes. The last question, list out the various defects in casting. This is very important. So the first type, that is blowholes, then slaps, honeycombing, swells, shift, cold shut, hot tears, fins, internal air packets, and runout. These are nothing but few types of defects that found inside the casting or over the casting.